Here we go with some Avogadros Law practice problems. Now with these practice problems, you should work them out for yourself first, come back and check your answers. So that's how this should work out. So you should have already done numbers 1 and 2. We look here and we always identify first our three variables. We have 5 liters of gas, 0.965 moles. So this right here is going to be V1. Moles, that's going to be N1, and then we're given N2, 1.8 moles, N2. And we are going to solve our new volume. We are solving for V2. So V2, this right here, this is our unknown. We don't know what V2 is going to be. With that in mind, this right here for this question, we don't know V2. So we're going to have these three. What is our volume 1? It is 5 liters. That is our first volume we are given. So 5.00 liters. We don't know V2. That's our unknown. Solving for V2. We'll put in X for V2. Our N1 we labeled right here. The first moles that are given to us in the problem, 0.965. And our N2 is 1.80 right here. So let's go ahead and draw in our, whoops, always. All right, there we go right there. There we go right there. Equals, okay, there we go. That is our equation. Then we are going to cross multiply 5 times 1.8 right there. So we end up, we first need to do 5 times 1.8. 5 multiplied by 1.8. That's going to give me 9. That is going to give me 9. So 9 is going to equal 0.965x. We then just divide by 0.965, because that's what's next to the x, so divided by 0.965, that'll get the x by itself, divided by 0.965. In the end, when I do 9 divided by 0.965, I'm going to get 9x equals just go to 2 significant digits, 9.3, and we were solving for volume, so our new volume is 9.3 liters. That should be the answer you got for 1. All right, let's go on to 2. First thing we do, identify the 3 things we're given. A cylinder with a movable piston contains 1 mole of helium. More helium is added to the cylinder and was adjusted so the gas pressure remains the same. The volume was adjusted so the gas pressure remains the same. How many moles of helium were added? So we're solving for how many moles. So we're solving for moles if the volume changed from 2 to 2.7. So this is our first volume we're given, so this is volume 1. This is our second volume we're given, so this is volume 2. And this up here is the only thing of moles we've been given, so that is going to be our N1. We are solving for N2. N2 is going to be our unknown. So our volume 1, 2.00 liters. Our volume 2, 2.70 liters. Oops, there we go. Our N1 is 1 mole. Our N2, we don't know, so we're going to label that as X. Set up our proportion here using this equation that's so elegantly written above you. Right there, right there. And then we cross multiply. You end up getting 2x. 2x equals 2.70. Divide by 2. Divide each side by 2. So we would take our handy dandy marker here and divide by 2 right there, and divide by 2 right here to get the x by itself. So you do 2.7 divided by 2 to solve for x. Let's figure out what that is. 2.7 divided by 2 equals 1.35, and we are solving how many moles? 1.35 moles of helium were added if our volume changed from 2 to 2.7. So that is my answer right there, is 1.35 moles. So those are your first 2 examples. Let's go ahead and look at 2 more examples quickly. First, again, same concept, identify, identify, identify. Your N1 right there, 0.11 moles. Your V1, 0.09 liters. and your V2, 0.75 liters. You almost don't even need to read the whole question. You just need to identify your different variables there. And then we're solving for how many moles of gas. So we're solving for N2. So our V1, that was our first set of liters. So our V1 would be 0.09 liters. Our V2 right here, 0.75 liters, came second in the problem. Our N1 is 0.11 moles, and we don't know our N2, so we're going to label that as X. Same thing, set up our proportion here, equals, this one's really close together, so we're going to have to be careful with our equal sign. It's a fantastic equal sign if I do say so myself. And then we are going to cross multiply again, boom, boom, end up with 0.09x equals 0.75 times 0.11, 0.75 multiplied by 0.11 is 0.0825. Divide by 0.09 on each side, so we would take our handy dandy pen here to switch colors, go to purple, divide by 0.09, excellent handwriting, thank you, divide by 0.09, and in the end, when we divide that out, X is going to equal 0.92, rounded, of course, moles, because we are solving for moles of gas. So right there, 0.92 should be your answer for number 4. Sorry, for number 3. Number 4, last example for this video. Again, I know it's getting repetitive, but I mean, just keep doing the same thing. Identify, identify, identify. So, you need to fit your spare tire into your truck. You know your truck only has 13.1 liters of space. The tire is currently 15.4 liters. So this here is our V1. V1. And this here is our V2. V2. And it contains 6.2 moles of gas. So moles, that is our N1. How many moles of gas should you release in order to get the tire down to 13.1 liters? This here is the same as our V1, 13.1 liters, so we don't need to worry about that. So our V1 is 13.1 liters. Our V2 is 15.4 liters. Now, this one is a little bit tricky, just a little bit, because you need to fit your spare tire into your truck. You know it only has 13.1 liters of space. Currently, it has 15.4 liters and contains 6.2 moles. So this right here actually is going to go in the spot of N2 strictly because it needs to match up with the 15.4. Does everybody see that? Because it's 15.4 liters and contains 6.2 moles. So that actually needs to match up with the 15.4. So that's one rare case, a little bit of a challenge problem here. One rare case where it's going to be switched up just a little bit. And that is a case where you definitely need to make sure you read the whole problem. I kind of said earlier, you just identify the variables, but when you get to some of these more challenging problems, you definitely need to make sure you see what matches up with what. But you see 15.4 liters contains 6.2 moles of gas. So those two have to go together, and 13.1 liters has to be over X in this situation. So we'll cross multiply here like that. So you get 15.4X equals, and then we do 13.1 multiplied by 6.2, and that's 81.2. And then we divide by 15.4, of course. Divide by 15.4, divide by 15.4, right there, 15.4, 15.4, and 81.2 divided by 15.4, my x equals 5.3 is what I'm going to round it to. And that is right here. It says, so the question is another thing you should make sure you certainly read what it's asking for. It says, how many moles of gas should you release in order to get the tire down to 13.1 liters? Well, my x here equals 5.3 moles. But what that represents is the number of moles that matches up with 13.1 liters. So we have to get to 5.3 moles. We're currently at 6.2 moles. So how many moles of gas do we need to release? We'd have to do 6.2. Let me write it out right here for you. In this situation, you have to be 6.2 minus 5.3, and that's going to equal 0.9 moles. So you actually, 0.9 moles. You're actually going to have to release 0.9 moles of gas. The reason is we started with 6.2 and 15.4 liters. In 13.1 liters, that's going to hold 5.3 moles of gas. But what the question's asking is how many moles we have to release to get from 6.2 to 5.3. So then that's going to be the difference. That's a little bit of a challenge problem right there. So if you got that one right, well done. But check your work here. That's some good Avogadros Law practice for you, those 4 questions. Farewell.